Perfect. Okay. Okay, so today we're going to go over mean, median, mode, and standard deviation. Okay. So if you have a pencil and a notebook, go ahead and start writing down what we'll go over in the notes. I'm going to share my screen real quick. Okay. Okay, if you can log into StatCrunch at this point, just so that you have that tab open. Okay, because we will be using StatCrunch. Is anybody still not on StatCrunch? Okay, good.
I'm not. I can't sign in.
Okay. Who's not in StatCrunch?
Jason.
Jay Sean?
Yeah.
Okay. Amanda, I'm going to send you with Jay Sean to get him set up on StatCrunch, okay? I'm going to create a breakout room. Okay. And add a room. Okay. So Amanda, I'm going to move you to breakout room 2, and Jashawn, I'm going to move you to breakout room 2 as well. Once you get the notification, Jashawn, go ahead and click on accept. Okay. I don't know where Luis went. Okay, who else do we have here? Jalen. Jalen, can you hear me or see me?
Professor, what did you want me to do with Matt?
With Matt?
Yeah.
Nothing. There's no Matt in here.
Matt Cabrera? You sent me and him to a breakout room.
Oh no, I just opened the rooms. I have to tell him to come back.
Okay then.
Or
yeah, he was
could,
a bit confused.
If you could, I opened them up. You only Amanda and Jay Sean were supposed to accept the invite.
Yeah. Do you think you could send me back so I could tell him?
Yeah. I'll send him. Okay. You should be able to move yourself, but whatever. Okay. So the issue with Gradescope has been resolved. So if you were not able to get on Gradescope, you should be able to automatically get on now. Okay. Okay. So let's start going through today's material. Okay. Let me share my screen. Okay. I'm gonna mute everybody for right now. And if you have a question, you can always unmute yourself. Okay. Okay, perfect. Okay, and once again, if you have not put your name in the chat, make sure that you do that for attendance purposes. Okay, so today we're going to be talking about mean, median, mode, range, and standard deviation. Okay, so mean, median, mode, range, and standard deviation. Okay, let's start with the mean. The mean is the average. Okay, the mean is the average number. Okay, so how do we find the average? It's the sum of all the data over the number of items. Okay. The median. What's the median? The median is the middle number. Okay, the middle number, or we're going to say the middle value, because it's not always the middle. There's not always a middle number. Okay, we're just going to say the middle value of our data set. What about the mode? The mode is the value, or we'll say the data, the datum that occurs the most. Okay, the range. Okay, the range is the largest minus smallest value. And the standard deviation is a measurement of how spread out the data is. Okay. Okay, so I'll leave you, if you haven't finished copying that down, I'll let you finish copying that down there. Okay, so we're going to find the mean. Let's look at the mean for certain values. Okay, so the mean here, okay, of 4, 5, 5, okay, 4, 5, 5, 5, 6. So let's look at the mean for this guy. Okay, what's the mean going to be? Well, we're going to add up all the numbers and divide by how many there are. So let's do that. 4 plus 5 plus 5 plus 5 plus 6, okay, is equal to what? Well, I'm going to grab my handy dandy calculator here. Okay, and I'm going to say 4 plus 5 plus 5 plus 5 plus 6. Oh, that's 25. Okay, so when I add that, that's 25. And I need the sum over the number of items. It's the sum over the number of items. Well, how many items are there? Well, if I count them, 1, 2, 3, 4, 5, I get 5 items. And so this is 25 over 5, which is 5. Okay. Okay, does this make sense? Okay, does this make sense? Add them all up, divide by 5, that's the mean. Okay. Okay, what about the median? What's the median equal to here? Well, the median is the middle number. Okay. So we're going to look at these guys for the middle number, 4, 5, 5, 5, 6. We're going to look for what the middle number is, and that middle number is right here. It's in the middle. It's going to be the third number in, because there's 2 on one side, 2 on the other side, and the middle number is going to be 5. So that's the median. The median is 5. Okay. Okay, what about, what do we need next? The mode, the mode. The mode is the data that occurs most often. So what's going to be the mode here? Does anybody know?
5.
Say that again.
5.
5, very good. Who was that?
David.
David, okay. David, you're going to end up with a spin. Can Amanda and Luis, can you make sure that you give David a spin later on? That would be awesome. Okay, so yes, absolutely. The mode here is 5. Why? Because 5 occurs 3 times. 1, 2, 3 times. Okay, what about the range? What about the range? The range here. Well, the range is the highest number. Well, the highest number is 6 minus the lowest number. Well, that's 4. And so the range is 2. Okay. Standard deviation. Okay, I'm going to come back to that one. Okay, because in this class, we're not going to do standard deviation by hand. Okay, it's not necessary. We're going to actually let StatCrunch do standard deviation for us. Okay, so we're gonna come back to standard deviation on this data set. Let's do one more data set. Okay, let's do one more data set here for these. Okay, and let's see what we got here. So let's do 1, 2, 3, 9, and 10. And what I'd like for you guys to do is take a couple of minutes, and I want you to tell me what's the mean, what's the median, what's the mode, and what's the range. Okay. Okay, so I'm gonna wait a couple minutes for you guys to work this out for this data set. Okay, and I want you to post, okay, in the chat what you got for each of these. Okay. Okay, so I'm going to go back to sharing my screen. Sorry about that. Okay. So I want you to tell me what's the mean, the median, the mode, and the range. Okay. And then post your answer in the chat. Okay, awesome. David says the mean is 5 and the median is 3. Okay, Jayshawn says the mean is 5 and the median is 3. David is absolutely correct with no mode. That is perfect. And Jayshawn, you're correct with the range being 9. Perfect. Okay, seems like everybody understands the concept. Now let's go to standard deviation. Okay, that's kind of the main topic of today is what the heck is standard deviation, and how do we deal with this concept of standard deviation? Okay, again, we're not going to go into a lot of the how you calculate standard deviation. That's more for a more technical class than what we're doing right now. I just want you to understand the concept behind standard deviation a lot more than the nuts and bolts of actually how to calculate it by hand. It's again, we live in a day and age where we have computers and calculators, and we're going to utilize the technology. Okay, so a couple of things. Okay, we're going to go back to our two data sets here. So let me go down here and let me rewrite our two data sets. So data set 1, that's a 1, sorry. Okay, data set 1 is 4, 5, 5, 5, and 6. And data set 2, okay, is 1, 2, 3, 9, and 10. 1, 2, 3, 9, and 10. Okay. Okay. So the standard deviation is a measurement of something called spread. Okay, it is a measurement of spread, how spread out something is. There is data that is very spread out. Okay, there's data that's very spread out, and then there's data that is not spread out as much. Okay, do you see how the first data here, the first data is very spread out, okay, large spread, whereas the data in my second diagram has small spread. Okay, so if we look at data 1 here, okay, and so the standard deviation is a measurement, it's a number, it's a value that tells me how much spread there is. How is it large spread or is it small spread? So let's look at data number 1 here, and let's see if we were to do a dot plot on data 1, right? If we were to do a dot plot on data 1, we would go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And at 4, 5, and 6 is where the data lies for data 1, right? So for data 1, we're going to be at 4, 5, and 6. Okay, and so I have one value at 4, I have one value at 6, and then I have 3 values at 5. Okay. Let's look at data 2. Okay, at data 2, we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we have 1, 2, 3, 9, and 10. We have 1, 2, 3, 9, and 10. Okay, so which one of these data has larger spread? Which one of these has the larger spread of data?
Data 2.
Isn't it data two?
Yeah, exactly. Very good. It absolutely, it is data 2. Data 2 has the larger spread. Data 1 has smaller spread. And so what we're going to say is that data 2 is going to have a larger standard deviation. Okay, it's going to have a larger standard deviation. Have a larger standard deviation. Okay, so data 2 is going to have a larger standard deviation. Okay, so how are we going to calculate the standard deviation? Well, we're going to do that through StatCrunch. Okay, so right now I'm going to share my StatCrunch with you. Let me know if you can't see my StatCrunch. Okay, but I'm going to go to StatCrunch right now, and you can log in as well. And I want you to follow along and do exactly what we're going to do. Okay, so you're going to open StatCrunch. And we're going to put in our values. In the first column, we're going to type in, okay, 4, 5, 5, 5, and 6. That goes in our first column. Okay. Okay, in our second column, we can do 1, 2, 3, 9, and 10 in our second column. Okay, so I'll give you a second to catch up on that. Okay. Okay, when you're caught up, just give me a thumbs up. Okay, give me a thumbs up if you have this entered.
What's our username for StatCrunch? It's our email again, or
Yeah, I think you might have used your email because I kind of suggested that so you'd have an individual, like a automatic unique username. So try that first. If not, we can try and find it later.
Okay. Okay. Does everybody know how to use the thumbs up in the participants? So you go to participants and then you click on the 3 dots and then you do a thumbs up. So if you have this entered into your screen, go ahead and give me a thumbs up. Okay, so I've only got 1 thumbs up so far. Okay, or a hand up, I guess. Let's try to do a thumbs up.
where do we go from the beginning? Because I just barely logged in.
How do I get to that?
How do you get to the thumbs up? You go to participants.
The chart. I'm logged into StatCrunch and I can't find it.
Yeah, so we're working in StatCrunch.
Yeah, I'm signed in. I just can't find the chart to input the numbers.
For StatCrunch?
Yes.
So were you able to log into StatCrunch?
Yeah.
Okay. And you weren't able to type the numbers?
Yeah, because I can't find the chart.
Okay, because it should automatically populate that chart. So you're
How do
either
you get
you're
to the
either
chart?
logged in.
On the top, I believe, just click go to StatCrunch. It should have a button, and it'll
Okay.
take you to the graph or to the to write down the numbers.
Okay.
Do I click my data?
No, don't click your data. There's like a big picture that says go to StatCrunch or go to something.
It says, oh, open StatCrunch. Here we go.
Open StatCrunch. There you go.
Oh,
Thank
all
you.
right, I got it.
You got it?
Got it.
Okay.
Just yeah,
Sorry.
just click on that and it'll take you to that thing.
And you
Okay.
said we plug in our data?
Yeah, see, I'm going to click on open StatCrunch.
Professor,
Okay.
you're not sharing your screen.
I'm not, I'm sorry. You're right. I'm not. Is that better? Okay, can everybody see my StatCrunch now?
Yeah.
Okay, so I'm gonna actually click out of that one. Okay, and here's my data. Okay. Okay. So Amanda, can you make sure that Gabriella is in the right, or sorry, Gabriella is in the right class?
Yeah.
She is?
She's supposed to be here.
Okay, perfect. Okay, thank you. Okay. Right. Okay, sounds good. Okay, is there anybody that does not have the data in StatCrunch at this point? Let me know. Is there anybody that does not have the data in StatCrunch at this point? Okay. Okay, so here's how we're going to get standard deviation. Okay, the standard deviation. And we're going to go to the stats. If you see where I'm at stat. Do I want stat or do I want data? I want data, I'm sorry. Is that right? No, I want stat, I'm sorry. I do want stat. I want stat, and then I want summary stats. Okay, so stat, and then summary stats. And then it'll say columns. It's not wanting to show up for some reason. Let me do it with a mouse. Okay, so summary, you see how this says columns here? Stat, summary stat, and columns. Okay, stat, summary stats, and columns. Okay, you'll get a screen that looks like this. And it says, select which column. Well, which column do I want to work with first? Well, I want to work with variable 1 column first. So I'm just going to click on that. I might be able to do both at the same time. I don't know yet. We'll try it in a little bit. But then it asks me, what do you want it to give you? Well, n is what? Does anybody remember what n represents in statistics? Anybody remember what n represents?
Small n is a sample.
Yeah, sample size. It's the size of the sample. Very good. Good job. Who is that? Gabriella?
Yes, that was me.
Yeah. Okay. I give Gabriella a spin, please. Okay, in the second session. Okay. We want the mean, sure. We want the standard deviation. That would be good. Okay, so I'm gonna click on these. I'm gonna hold down Control, I think, to get more than. Yeah, I hold down Control to get more than one. Okay. The median I want as well, and I want the range. Okay. Mean, median. I don't think this is going to give me. Oh, and it does give me the mode actually. So let's do mode as well. Okay. So it's going to ask me, and I'm not going to. I don't want the sample size because I know that all of these are of size 5. So I'm going to hold down Control and undo that. So it's going to give me the mean, the standard deviation, the median, the range, and the mode. So you can individually select these by holding down the Control key on the keyboard. Okay, so you just hold down the Control key and then you individually select these. Okay, and then I'm just going to go down here and I'm going to go compute. At the very bottom here, it says compute. Okay, if you could see that. Okay, compute, and it tells me that what? It tells me that the mean was 5, which we already found, that the mean was 5 for the first column. That's this first column here. Okay, the mean was 5. The standard deviation, the standard deviation was 0.707. So I'm going to remember that. Okay, it was 0.707. The median, what was the median? The median was the middle number. That's right here. That's number 3. In row 3, that was 5. What about the range? The range was from 4 to 6. So 6 minus 4 is 2. That is the range. And then the mode, what's the mode? Well, the mode is 5. That's the one that occurs most often. Okay. Okay. So now we're going to do the same thing, but do the same thing with the second column here. And in the chat, I want you to type the standard deviation for column 2. Tell me what's the standard deviation for column 2 by going to Stat, Summary Stats, Columns, okay? And for column 2, tell me what is the standard deviation for column 2. Right? So what's the standard deviation for column 2? So for data set 1, we found that we had a standard deviation of 0.707. That was our standard deviation. Okay, for data 2, we're going to get a standard deviation of what? What do we get in column 2? Yeah, very good. 4.18. I'll say 4.183. Good job to everybody. 4.183. Nicely done. So that's the standard deviation, okay, of that one. Which one has here the higher standard deviation? Which one has the larger standard deviation, data 1 or data 2?
Two.
The 2?
Yeah, 2, definitely. We already kind of knew that, didn't we? Right? Because of what? Because what is standard deviation measuring? Isn't standard deviation measuring the spread? Right? So wouldn't the standard deviation for data 1 be a lot smaller? It should be a lot smaller than the standard deviation for data 2. because this data is more bunched together. It's closer together, so it's going to have a smaller standard deviation. Small spread equals small standard deviation. Large spread equals large standard deviation. Okay. Okay. Let's go over a couple of notation reminders. Okay. So this is symbols that I want us to go back over. Okay. So for mean, okay, mean of a sample, here what we call sample mean, our symbol for sample mean is X bar. Okay. Okay, our mean for a population is a Greek symbol, and it looks like this. Okay, it's a U with a little tail on it. Okay, and we call that mu. Okay, mu. Okay, Mew, not to be confused with Mewtwo, who is a Pokemon. Okay, but this is just Mew, not Mewtwo. Okay, so Mewtwo was a clone of Mew. And so we're not talking about Mewtwo, who was the clone of Mew. We're just talking about Mew. Okay? So the mean of a population is mu. Okay, what about the standard deviation of a sample? So the standard deviation of a sample, okay, the standard deviation of a sample is S, or sometimes it's written as S sub X. Okay, the standard deviation of a sample is S, or sometimes referred to as S sub X. Okay, that's the standard deviation of a sample. That's what we use. So in this case, we would have said that the standard deviation of data set 1, okay, or S of data set 1 was 0.707. Okay, the standard deviation of data set 2, S, was 4.183. Okay, so S, or S sub X, standard deviation. Okay, so what about the standard deviation of a population? Okay, if I know the entire population and I want to get the standard deviation, it doesn't come out of a sample. This would be like Major League Baseball averages. We can know the Major League Baseball averages for all the people in the Major League. Why? Because that's a population of players and we can know all the stats on them. Right? So if we're using a population and we want to find standard deviation, we use a Greek symbol called sigma, and it's a circle with a little hat on it. Okay, it's a circle with a hat. Okay, circle with a hat. Okay, on it, or we call this sigma. Okay. Okay. Okay, so in statistics, there are 3 characteristics. Characteristics. There are 3 characteristics we look for? And those are, okay, shape, center, and spread. Okay, so the shape, we're going to say, is it symmetric? And is it unimodal? Okay, and I'm going to explain what those mean in a second. Is it symmetric and is it unimodal? That's what I really want to know when it comes to shape. Is it symmetric or is it unimodal? Okay, center. The measure of centers that we're going to use in this class are called the mean or the average and the median. Okay, or the middle number, the median. Okay. For spread, we're going to use something called standard deviation. And we're going to use something called the interquartile range. Okay, we're just focused on standard deviation today. Okay, so the spread, how spread out. Now let's look at symmetric and unimodal. What does symmetric and unimodal mean? Okay, so if something is symmetric, it's a mirror image. If it's symmetric, it's a mirror image. Okay, we are symmetric as people because my right side is the exact same thing as my left side. Okay, so if you split me right down the middle, I'm mirrored on both sides. I've got one side of my face and I've got another side of my face. Okay, and so what if we have a graph that looks like this, okay, we say that this is symmetric. And we say that it's symmetric about the mean, mu. Okay, so we would have mu here. And unimodal means that it has one hump is unimodal. It means there's only one mode. Okay, so symmetric, mirror image. Unimodal means there's only one hump. And that's what we're looking for in statistics. Because we can do a lot of statistics with stuff that is symmetric and unimodal. If it is symmetric and unimodal, we can do a lot of stuff with it. If it's not symmetric and not unimodal, we can't do as much. Okay, we can do some things, but we can't do a whole lot of things. So what's an example of something that's not symmetric? Well, if I had a graph that looks like this, okay, this is not symmetric. And it's actually something called right skewed or right tailed. Okay, it is right skewed or right tailed because the tail, think of this as, you know, like a guy, okay, with a little I don't know, glob, okay, little monster glob. And if I were to draw this monster blob, okay, he's gonna like eat the city. Okay, this little monster blob, well, where's his tail? Well, his tail is over here. And is it to the right or to the left? Well, it's to the right. So we say that it's not symmetric and it's right skewed or right tailed. Okay. Now, what would be an example of something that's not unimodal? Well, an example of something that's not unimodal would look like this. Okay, we would say this is bimodal because it has two humps. And two humps means that it's bimodal. Okay, it is not unimodal. Okay. Okay, and that's where I'm gonna leave off for today. Okay. Okay, I'm gonna leave. I'm gonna let Amanda take over, or Luis. Is it? I think is it Luis that's taking over? Okay, I'm
Yes.
gonna do that right now. Sorry. I'm gonna make Luis host right now. So Luis has host privileges. Remember to give the people spins that I said earn spins. Thank you very much, Luis.
Mhm.
And Amanda, and I will see you guys. What's today? Thursday. I will see you guys on Monday. Okay. Okay. See you guys later.
Thank you.
Yeah, you're welcome.
Luis, do you have the worksheet for today?
Yeah, just setting it up so that not everything is viewed because they have the answers on the page. So
Where it's under modules?
Google Drive. It's in your Google Drive. If not, then
Okay.
then it should be on your email account. Angie sent. So we're gonna go ahead and get started with the assignment for today. It's just gonna be a mini expansion on standard deviation, mean, and those good stuff. So I'm gonna go ahead and start sharing screen. And like the previous meeting, I will recommend everybody joins in because this is for the benefit of you guys, not for me to tell you what's going on. All right. So at the moment, if you could see my screen, we're going to be working on our sample question. So give me a second. Let me find my. All right. So the key things to remember are your sample mean. Can anybody? Oops. Can anybody tell me what's the notation we use for your sample mean?
Isn't it a lowercase n?
No, that would be your sample size.
Mm.
So that's a good thing to bring up. Your sample size is lowercase n. Your population size will be uppercase n. So just make sure you kind of know the difference because we're going to be using these from now on.
All right.
So if we're talking about sample mean, did anybody got that from today's lecture? All right. So just to give it back to you one more time, the sample mean is just X bar. And your population mean?
A U?
You.
Yeah. It's not called U, it's a mu with the M.
Mu.
Yeah. That's mu, and it's drawn like the U. Okay. And then we also have your sample. I'm gonna call it sample standard deviation. What is that?
It's an X. I mean, yeah, S.
S, just an S. Or like he stated SX, but we're just gonna go with an X. And then we also have your population. Standard deviation. And what would that be?
A circle with a
Sigma.
heart on it.
Add on the
Yeah.
end.
Sigma.
So I will recommend you know these. This is mu and this is sigma. They go with your population. This is X bar and this is S. They go with your sample. So make sure you understand what their names are and make sure you understand what they're for. All right. These are the ones we're going to be using at the very moment. So let's clear all of this up and let's start reading. So your basketball team has 20 players. The points per game, the PPG points per game for the team are normally distributed. Here is the PPG for the 5 players of 2019 season. Adam got 25, Gus got 21, and Robert got 24, and Jack got 23, and David got 22. So we need now here's the important question. for the part. We need the standard deviation, so we already know what we're looking for. And will we calculate it for the sample or the population? Does everybody remember what the sample or population difference was from Monday class? So that's making a comeback again. Is this a sample or a population? Can anyone tell me?
A sample?
Just a sample, because we're only including parts of the team. We're not including everything. All right, so this is just a sample. So what are we going to be looking for? We're going to be looking for the sample standard deviation, meaning we're going to be looking for S. Okay, so you are correct. We are looking for the sample standard deviation. All right, and we're looking for the sample mean as well. So question number B, or letter B. What is the mean? So can anybody tell me what the mean is, or what are we gonna do to get the mean?
Isn't it like the average?
Add
The
it all
average.
up.
Add them
then
all up.
Divided
So
by the number that they're.
Can anybody tell me what is the sample mean?
21. Is it 21?
Sorry, one more time, louder.
Can anybody tell me what the sample
No,
mean
no, no.
is?
Sorry, just
Oh.
Sean. I think he said something, but I couldn't hear it.
21.
The sample mean wouldn't be 21. I think you're thinking of something else. The sample mean is add them all up. So it'll be 25 plus 21 plus 24 plus 23 and plus 22. Whatever that gives you, you divide by, what number would you divide by?
5.
By 5, because you have five data points. So it's 25 plus 21 plus 24.
I got 23.
22. Give me a second. 23?
Yeah.
All right, so let's see. Yeah, sorry. My mistake. I was thinking of something else. But yeah, you were correct. I think Jay-Sean, you said 23 too?
I said 21.
Oh, 21. Okay, yeah. So you were a bit off by 2 points. Maybe it was a miscalculated amount. But whoever said 23, good job. It was 23. You should have gotten 115. And then divide 115 by 3. Okay. So this is the only one we're actually going to probably do it by hand. The rest we're going to be using StatCrunch, and you guys are going to be helping me out with that. Okay, so next question. What is the standard deviation? And this is where we kind of talk about we don't really want to do the standard deviation by hand. It's going to take too much time, and it's not going to help us out that much in the long run. So what we're going to do is we're going to plug in our data points on StatCrunch. Can then everybody see my StatCrunch?
Yeah.
All right.
Yes.
So let me sign in. Open StatCrunch. And what you're going to be inputting, so make sure you guys are opening your StatCrunch as well, because we're going to be doing the rest of the problems with your StatCrunch, and you guys are going to be doing them. So just open up your StatCrunch and then write your, so let me write down your name. So Adam, Gus, Robert, Jack, and David. Gus, Robert, Jack, and David. Then we need our points, which is just 25, 21, 24, 23. So it's 25, 21, 21, 24, 24, 23, and 22. All right. So like Professor Hultman said, type in your data. How do we find our standard deviation? Does anybody remember?
You gotta go to stats.
Go to stats. What do we do?
and then put summary like column.
Summary stats. Yeah, sorry.
Summary stats.
Column, and we're gonna be clicking our VR2. You could name them, but I'm not gonna name them for the sake of time. So if you were to name them just for this one, you could just double click and type in names and then PPE or points per game. Yeah.
Oh yeah.
PPG. And then when you go ahead and click your summary stats, you can already tell which one it is. PPG, that's the one we're looking for. And right here, it's going to give us all the things we really need. We really don't need these at the moment, the range, the min, the max, and all of that for right now. We just want to look at that, and you could just pick and choose when you can. But for time's sake, I'm just going to choose all of them. So then our standard deviation, where would that be?
1.58.
1.58.
1.581138. So you could probably, the best thing you'll want to do is probably round out to the 4th decimal. That'll give you a lot of information. So it would have been 1.5811. So when we go back to our chart, we would, again, the sample mean, which would have been X bar. So X bar equals 23 points. And then how would I write standard deviation?
Going to be S equals
S, because we're talking about sample. S equals what? 1.58.
1.5. Yeah.
Yeah, 1.5811, I think. So yeah, that's how you'll go ahead and do that part. Yeah, 1.5811. And then you'll be done. That will be it for the standard deviation. And you can see they actually rounded off to the 2nd decimal, but it's okay. What I will also recommend you do on StatCrunch is before you even click on your summary stats. So let me clear this up actually, because it's going to be everywhere. So before you even go on your summary stats, what you want to do is create a histogram. So you were learning that in this section. So go to graph and click on histogram and then type in the one that you want, which will be the points per game, and just press compute. It will look like this. And what you'll want to do is describe the shape, the size, the shape, the center, and the standard deviation just by looking at it. The shape, what does it look like? It looks uniform. So that's something you'll learn eventually. But the shape, it just looks like they're all even. The mean would be somewhere in the middle. Where would the mean be? If you were to take a guess, what would the mean be?
23.
23. Which what you have in reality, right? You ended up getting the sample mean to be 23. So you'll want to take a guess when you look at your graph, be like, where is our mean and what would the standard deviation be? The standard deviation doesn't really look much, but it'll look like it's about 1 or something like that, right? Because they're spread apart by 1. And so that's what your estimate would be just by looking at it before you even start at answering the question. Okay, so you could get an idea of what your answer should be. So let's go ahead and quit this and move on to the next one. All right, so that's standard deviation and that's mean. Now we have this one. Okay. So here are the finishing times for every team in the relay race. 27, 29, 19, 31, 89, and 42. So although the data is skewed, the newspaper wants us to report the standard deviation. Will we calculate diff for a sample or a population? What are your thoughts? Would this be a sample size or would this be a population size? So reread the question very carefully and tell me what it is. Okay. Anybody has a guess?
Sample?
Population.
Population. Thank you, I didn't saw who that was.
Jay
It is
Sean.
population. Oh, Jay Sean, thank you. Because we're talking about every team in a relay race. If we're talking about every team, then we're taking the whole population of that relay race, okay? If by any chance we were just talking about the lions, or we were just talking about the koalas, then it will be a sample size, okay? But we're not just talking about one part of it. We're talking about the whole population of the relay race, okay? So this would have been this would have been population. So that means our standard deviation and our mean are going to be what? What would your population mean be? I mean, what letter or what symbol? For
Population mean?
population mean.
Mu?
Mu. Yes. And then for population standard deviation?
SX, right?
That would be sigma.
Sigma.
Okay. So the Greek letters go together. So if you have a mu, you have a sigma with population mean and population standard deviation. And if you have a sample mean, x bar, then you have a sample standard deviation with s. Okay? So just a little way to understand them is just put these two Greek in their own, just put them together when you think of them. Sample population, population mean and population standard deviation is just mu and sigma, Greek letters. Okay, so let's keep moving. Again, like I stated, your answer was correct, population mean and population standard deviation. So I think you kind of saw it. What is the mean? What, like I stated before, who wants to show their work using StatCrunch? So before we actually get started on this, take out your StatCrunch and just write what you see, like I did right here, but on your own. And then whoever wants to share could share, and whoever shares gets 3 spins.
Do we do it with the finishing teams, or do we do it with the names?
You can't really do anything with the names. So the way I did it, right, you just write down the names on the left and then write down the minutes on the next column. And the ones that you're going to be taking is the columns, the PPG, in this case are numbers, because you can't really get data from names. Or, you can't really have calculations using names, all right? So you're going to get the number ones.
Do we need to put down the names, or can we just put down the numbers?
You could just skip the names. It'll be a lot faster. So you could just go ahead and write down the minutes. But for actual data, you have to put down everything.
All right.
But for this case, it's okay.
Do you need to answer?
Yes, we need what is the mean. But before you show it, who wants to share their screen so they could show us how they're doing it?
I'll do.
All right, that was Jay Sean?
Yeah.
All right, then. So in a minute, I'll stop sharing, then just share your screen. Okay?
Right.
I'm just letting everybody input their data. All right, so I'm gonna go ahead and click stop share, and then Jay Sean, do you know how to share your screen?
Yeah, I just click
Alright.
share screen, right?
Yeah, go for it and share us your StatCrunch.
Oh.
All right, so you got the time in. So what do we do if we want to get the standard deviation and the mean?
Here.
Go for it.
Click that one.
And like I stated, you have your choices of the ones that you want. Just click on the ones that we don't need. There you go. So we just really need the standard deviation and the mean. So if we were to compute that, what would our mean be and what would our standard deviation be?
28.31.
Correct for the standard deviation
39.
and 39 for the mean. So, all right, thank you, Yeshan. Can you stop share? So now how would I write it? How would I write the mean? So we have our answers here.
Isn't it X?
Give me a, were this the same thing you got? Oh,
No.
Jayshawn, I believe you missed one. Because you had 5 data points, we needed 6 data points. So I believe you missed one.
Can I reshare again?
Yeah, reshare.
All
Do
right,
you have
okay.
the one that you're missing?
Yeah.
Okay then. So yeah, just make sure when you do this, you get all the data points. As you can see, our answer came out incorrectly.
It was 42 I was missing.
Yeah, you missed the 42.
There we
So
go.
you got 25 and 39.5.
Yep. That's the answer.
The standard deviation seems to be a bit weird. Let me just double check. So you got the 27, 29, 31, 19, 89, 42 minutes. I'm not so sure why the answer is a bit off in my section, but let's just go with what you have. The mean is correct, but the standard deviation seems a bit off. But it's all right. Data tends to be a bit here and there. So I'll go ahead and share my screen again. Okay. So if we were to write this, how would you write down the mean? What would you use?
Is it population or is it
Use
population? Right?
mu, right?
Mu. So mu is equal to 39.5 minutes. Okay. And then right here, we will put the standard deviation, which is sigma, is equal to, I'm going to use your answer, 25 point, I don't remember the rest, but up to 2 decimal places, all right?
Yeah.
Minutes. So that's how you'll write it down for number 2. We'll have your mu and you'll have your sigma. Okay, so let's move on to the next one. Give me a second. All right. So now it says here the batting average BA of several Hall of Fame baseball players are listed below. As you can see, we have all of these data points. I'm giving away all the answers. Okay, we need a standard deviation. Will we calculate it using a sample or a population? So give me a second. Here's the career batting average of several Hall of Fame baseball players. So the key word right here would be several. So are we talking about population or are we talking about a sample?
A sample.
A sample, right? Because we're not talking about all of our Hall of Fame baseball players. We're only talking about a few of them, which would be these right here. Okay. So now if we go ahead and input that data.
I cannot hear you.
Oh. Give me a second. Can you hear me now?
Yeah.
All right then. So we're just talking about a sample size because we're only talking about several Hall of Fame players, not all of them. So if we were to go ahead and input that data, go ahead and start plugging things in your StatCrunch. And who would want to share their screen so they could go ahead and do the standard deviation and the mean. So again, whoever does it will get 3 spins. Jayshawn, at the moment, I would recommend you don't share your screen so everybody else could get a chance to share. So let me know when you're done with the data points. Sorry. All right. Anybody got all the points yet?
Yeah, I have all of mine done.
All right, then. So I'm gonna go ahead and click stop share, and you could go ahead and walk everyone through how you're gonna find the standard deviation and the mean. All right. Do you know how to share screen?
Yeah.
All right, then go for it.
Is that sharing?
Yeah, so you're gonna click on your summary stats.
Can't get it. So I go over here. This one. Like, what are we looking for? Mean?
Yeah, mean and standard deviation.
Oy. Oh my god.
So I think you could press Control and then click
Is
another
it
one to
playing?
select two of them. Or
What the heck?
so there's a way to do it.
Oh, okay.
There you go. You got
It
it?
was command, not control.
Command, sorry.
Okay.
And as you can see, what would our standard deviation and what would our mean be?
The standard deviation would be 0.0925, or and then the mean would be 0.265.
The mean 0.265. So let me see your data sets because we're getting different numbers. So, and let me just compare it with mine's.
Because when I would put zeros for here, it just
No, that won't change anything. So give me a second. So let me just check. 0.305, 0.366, 0.325, 0.284, 0.31, 0.3, 0.279, 0.34, 0.125. I think you're missing a few data points in there. But overall, you know how to work it. So you could go ahead and stop share. 3 spins for Gabriela, because at least she knows how to do it. And that's the important part, knowing how to do these things. Just make sure when you write these things down, you get all your data points and try not to miss one. Because if we do our summary stats, column, I'm actually getting a mean of 0.256 and a standard deviation of 0.0962. Okay. So that's actually going to be a big difference in what you had. And that's what our answer would be, which is what is our sample mean, which is 0.256, and then what is our standard deviation, which is 0.096. All right, so we have an extra question in the bottom. It says there appears to be a large standard deviation, 0.096, which seems strange since these are Hall of Fame players. What is the logical explanation for the large standard deviation? Does anybody want to take a guess? So if you remember talking about standard deviation does spread. Spread means that our graph looks a bit, the points don't look clustered together. That's what it means. So it means it's a bit more spread out. And it's saying that since these are Hall of Fame players, if you're a Hall of Fame player, you should have a very high or career batting average. So you should be closer to everybody else. So you should be in a cluster. Why does it has a large standard deviation? Can anybody try to explain that? At least take a guess or something.
There's a lot, because it's a big group, so
Not necessarily,
Because they're hitting the same?
but sometimes, yeah. Sometimes big groups might.
Because they're hitting the same?
Okay, so you guys are on the right track. You guys
Different
are thinking of.
positions.
There you go. So there is a large standard deviation because the pitcher are also inducted to the Hall of Fame, since pitchers typically have very low batting averages. So what it means by very low batting average, you can see right here, you have Holt Wilhelm. He has a batting average of .088. Compared to the rest of everybody else, you have batting averages of .305, .3, .279. These are the ones that are going to be within the cluster. If they were within the cluster, those would be the ones that are close together. But then you have batting average such as Sandy Koufax or let's see, who else? Or Randy Johnson, where they're 1.1 or below. So these right here, Lefty Gomez as well, would change the data since they will be more spread out. So actually, let me see if a graph would show you what I'm talking about. So let's do a histogram for this one. So as you can see, everybody see the graph?
Yes.
If we didn't have those pitchers with the low batting average, as you can see right here on the left, which is 0.1, those your standard deviation would have been smaller because then the rest would have been in this cluster over here. As you can see, then our standard deviation would have been smaller. But since we have those batting averages of the pitchers, they're making the data more spread out, and they're just making the data more spread out, meaning your standard deviation will be bigger. Okay, so looking at points or data points sometimes will help give you a sense of what the standard deviation might be. All right. Anybody lost on that, or everybody good?
Good.
All right then. So let's move on to the next one. Pizza Hut is interested in analyzing. Oops. All right. Pizza Hut is interested in analyzing some of its transaction data, which tends to be normally distributed. Here are the total of 15 random transactions. First question: is this a sample or a population size? Sample, right? We're not getting all the transaction data. They're not giving every transaction data they had. They're only giving us 15 random ones, okay? So now we're gonna go ahead and put this into StatCrunch. So if anybody wants to do that, go ahead and start typing things into StatCrunch. So that'll be that right here. Can you see both StatCrunch and the document?
Or no, do you I just see StatCrunch.
Oh, okay, sorry. Give me a second. All right. There you go. All right, now you see the document?
Yeah.
All right, so just type those in. And then whoever wants to be the next person to share could share their screen. And what we're going to do is something different. So Jayshawn and Gabriela could earn 3 extra points as well now. Anybody got the data in?
Yeah, I'll do.
All right, go for it, Jayshawn. I'm going to stop share. Actually, let me wait a minute or so everybody could get the rest. All right. So I'm going to go ahead and give the share screen to Jayshawn, and let's see what he ends up getting. Go for it. All right, so actually before you do summary stats, what I want you to do is go to graph. and look at the histogram. And then click your VR4 for the column and put compute. So if we have all the data correct, what would the shape of the graph look like? So we just learned a couple of shapes for that. What would the shape of the graph be, Jayshawn?
This would be a spread, right?
Skewed right. You are correct. Because you have the tail going to the right. So this would be a skewed distribution. What, in your estimation, what do you believe the mean would be? What would the middle, not the middle number, what would the average be overall?
Like, it wouldn't be the middle, so it wouldn't be 60. Would it be like 20 to 40?
20 to 40. Why do you say that?
Because the histogram, it's like in between the 20 and 40, right? And that's the most occurring.
Yeah, you're in the correct area. You're it's averaging in the middle of 20 and 40 because there's a lot of data points right there.
Yeah.
What would your standard deviation be? This one's a bit harder, but what do you think it will be?
It'd be a big number, right?
It'll be a semi relative big number. You are in the correct area. Give me a second. You are in the correct data because if you take a look at it, if our mean would have been around 20 to 40, then we still have these other numbers to get to for our standard deviation. So we're being spread out by a lot. So it will be a pretty large number. Do you want to take a guess?
Nah.
Okay. All right. But you know it's supposed to be something large, right?
Yeah.
All right. So go ahead and cancel that and now click your summary stats.
Okay.
Don't forget to put your mean in.
Okay.
All right. So your standard deviation is 23 and your mean is 39. Were you semi-correct with the mean?
Yeah.
Between 20 to 40, right?
Yeah.
It's better to try to narrow it down a bit more, but it's okay if you have a small interval as well. So you got it in between 20 to 40. At least you know where your mean is supposed to lie. And you said your standard deviation is supposed to be pretty big. Is that a pretty big number in your opinion? Yeah. So the main things that you want to get from just looking at a graph is the shape of it, which Jayshawn, what did you say it was?
Skewed right.
Skewed right. Your mean. You don't have to get it correctly, but you could take a guess. And the standard deviation. Again, you don't have to get it correctly, but you could take a guess at what it is. And once you find that, compare them to the actual answer. And Jayshawn seemed to be pretty spot on what he did. Give him an extra point on that. All right, so next one. Let's see. Share screen. All right. So what is the mean?
We have 8 minutes.
Yeah, I saw. We have like 6 questions. Yeah, I think maybe number 5 will be the last one. But so far, everything seems pretty good. Everyone?
Yes.
Okay, then that's great.
Yeah.
So how will we write this, Deshaun?
It's sample, so it'd be X bar.
X bar. So what would X bar describe?
The mean, right?
Yep, the sample mean. So
Sample
X bar
mean.
equals $39.40. And then standard deviation?
Oh, it's just the S, right?
S, yes. 23.83.
What is the other one called for population?
Population mean would be mu.
Oh, me.
So they call it mu.
No, for sample. Or for the standard deviation?
It'll
Yeah.
be sigma.
Oh, okay.
Sigma. Okay. So I will recommend you get to know you guys are getting used to this, but I would recommend when they ever ask you questions about these, you already know what we're talking about. If we're talking about population, mu and sigma. If we're talking about sample, X bar and S, okay? That will give you an understanding of what's going on in the class when you see two different things. When you see X bar, this is mu. So you'll know what we're talking about instead of being confused. All right, let's move to the next one. I think this will probably be our last one. So far, everyone's doing very, very good. Right here, listed are the lifespans of several world employees. Empires, my bad, not employees. I was thinking about that. These are the lifespans of several world empires. Would this be a sample or a population size?
Population.
Sample.
Sample. Why do you say that, Gabriela?
Because it says several.
And we're not talking about all the world empires, right? We're only talking about some of them.
Several, yeah.
It's a sample of the population. Jishan, I understand you put population, but do you kind of see why it's sample? Because we're not talking about all the world empires.
Yeah,
so,
I get it.
And we're only talking about a couple, several of them. So who wants, go ahead and put this in your StatCrunch. And let me know who wants to share. When anybody is finished, just let me know and we'll wrap this last question up, and we'll be good for today's session.
Are we going to do spins today?
Yeah, I'm trying to get this as quickly as done possible. So hopefully, oh, sorry. Amanda, can you just pull out the spinner?
Yeah.
Thank you. All right. Anybody got it?
Yeah, I got it.
All right. I'm going to go ahead and stop share, and you could go ahead and share your screen, Gabriela.
Oh.
Go for it.
Okay.
All right. So go to the histogram and make a histogram.
So I go here.
And just describe, just put world
computer.
empires.
Oh, gentle.
And then press compute. And just describe it to me. What kind of data is this? What's the shape of it?
So is it symmetric?
Is it symmetric? If you cut a line in the middle, does the left side looks like the right?
Okay, no. Then
So it looks
right skewed.
right skewed. It looks a little bit wacky, but it's still a bit right skewed. As you can see, you have the tail at the end on the right side. So now what would your mean be? You don't have to give a actual number. Try to give a nice estimate. Where would the mean land at?
Between maybe 400 and 600, maybe?
400 and 600, that's a good guess. It'll be a little bit better if you actually would have chosen the 200 to 400 one. As you can see, they're all of them, if we're talking about the average, if we were just looking at these three bars, right? The average would somewhere lie upon the middle bar. But since we also have this side of the right side, the last two bars on the end, the average will land closer to 400 than it would to 200, because that two bars at the end are pulling it to the right. But you're in the right track. What would the standard deviation be, or like what would your guess be?
Oof. Do I have to give an answer?
Not an exact answer. You could just probably give a little estimate, interval, if you want.
I honestly have no idea.
Okay, so that's fine. That's fine. You'll have to eventually. We'll work on that. So just cancel that and just go to summary stats and let's see what the answers are. And just press compute. That's fine. That's fine. Well, what is the mean?
391.5.
Is it closer to what I described? Somewhere in the middle, but closer to 400,
Yeah.
right? So it's 391.5. You were on the right track. 400 through 600 is not a bad guess, but there's a better one. And your standard deviation is pretty large because of those bars at the end. So 343.1. So good job, Gabriela. 3 points for you. All right, you could just go ahead and stop share, and we'll go ahead with those MVP points. Amanda, do you want to do them?
Yeah.
Go for it.
Wait, you just give Gabby 3 more points?
Yeah. For sharing.
Okay.
Okay.
All right, so I have Jalen has points, I think, from Tuesday.
From
I'm going
Tuesday?
to do his spins right now. Yeah, I forgot to do them on Tuesday when they left.
All right.
So he gets 3. Here's 1,
2.
2, and 3.
That's 8.
Okay. And
Just press reset.
7, right?
Yeah.
2, 3, 2, 7.
Oh, that's yeah. 6.
Yeah. Okay. Okay. So then I have Gabby has now 10 spins with this last share.
Okay.
I'm gonna do it 10 times.
Whoa.
All right, that will be 31.
Woo.
All right. For Jayshawn, I have a total of 5, including Tuesday.
Whoa. Whoa.
Yeah.
29.
All right.
What the heck?
And then for Matt, I have 1 spin. I think that was from Tuesday. And David's here, so he gets 2 spins. I think those are from Tuesday. Wait, did I clear it? I didn't reset it, huh?
No, yeah. No, just give him the 5 and just
No.
spin the one more.
Okay, so he has 5 and 2, total of 7. I believe I got everyone caught up.
All right, then. Good job, everyone. Thank you guys for sharing your screen and participating. For everyone that participated. And I'll see you guys next Monday.
Yep.
All right. Bye, you guys.
Bye.
Oh, I forgot to talk about Gabby. I forgot to talk to Gabby.
And send her a direct message on Pronto.
Yeah.
All
Okay.
right. So I'm going to go ahead and end it so we could go to the next one.
Yeah.